Welcome to Circuits Analytica. In this video, we will discuss the working of an operational amplifier as a voltage follower. The gain of a non-inverting amplifier is given as AF is equal to 1 plus RF divided by R1. If RF is equal to 0, gain of the non-inverting amplifier becomes unity. When RF is equal to 0, there is no significance for resistance R1, so it can be replaced with an open circuit. The resulting circuit is called as a voltage follower or buffer amplifier. This is how a non-inverting amplifier is transformed to a voltage follower or buffer amplifier. Replace resistance RF with a short circuit and resistance R1 with an open circuit. In short, in a non-inverting amplifier, if RF is replaced with a short circuit and R1 is replaced with an open circuit, then the non-inverting amplifier becomes a voltage follower or a buffer amplifier. Now let us discuss the applications of a voltage follower. For a voltage follower, input impedance is very high and output impedance is very low. So generally, voltage followers are used to isolate stages from each other. As the voltage follower or buffer amplifier can source large amounts of currents to the load, or it is a current amplifier, so it is used as an output stage in amplifiers. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, share and subscribe our channel.